Previously.
Why did it have to be snakes?
Converting a Python app to Rust. Got some foot guns there. Pretty steep learning curve. Let's go ahead and add an actual chat component. I'm going to bring Svelte back into the equation. And in the time that's passed, we're actually going to be using Svelte 5. Okay, so quite a lot has changed here. Let's go ahead and split horizontally, split vertically. Let's do this, CD components, let's do Rust. And let's see here, we've got a chat component now. So quite a lot here in the diff, but let's walk through it. So what we've done is added another top level directory for our chat component. And then we're also going to wire it up. So cargo, this will come in a second. Futures, that's for when we're doing streaming. Let's not deal with the components just yet. What we want to deal with is the scaffolding. So you can see here in our layout, we're going to add our component CSS, and then we're also going to pull in the JavaScript. And then for our chat template itself, we're going to bootstrap our chat Svelte component. For main, we're going to be adding in the standard delete, create, all that goodness. We're adding some more schemas and we're adding some more endpoints to be able to do proper chat functionality. So you can see here under the chat, and I'll pull it over to main in a second. So under our main, we have now top level get for the index. We're also getting a show, a stream, and delete. And that's just for main. Again, just some standard wiring up. Templates mod, we're gonna have a new template for chat. So we're gonna have a new object, which is gonna be similar title, username, and the actual JSON that we're gonna hand off to Svelte. And again, that's what this actual template file was. So just as a recap, we're gonna have the actual template file. That's gonna be our Jinja. We're gonna have the template struct that maps out what properties we're passing into the template. Let's go ahead and take a look at our actual controller to see the new logic we've added. And we've added a decent amount. So show is not gonna look too terribly different. So we're still gonna have that redirect. In this case, we actually are going to find the chat record. So get the user, get the chat based on the path from the URL. So we're going to have our app state, and then we're also going to extract the UUID from our URL. So that's what this is saying. And then our result is going to either be our chat template, or it's going to be an error that we could throw, which again could be like not found or any of that other stuff. So we're going to attempt to find the chat by the UUID. And if we do, we're going to get the JSON for it, which again is using our helper function from our model. And then we're just going to render the template. And that's all show is doing. Before I go too much further, let me go ahead and run. Am I in here? npm I. So let's go ahead and install it. And then let's do run dev.
Just build it. Yeah, it should be doing a out to components. Interesting.
And run build w. Wrong command. There we go. So we have two things. We'll come back to that in a second. So now we can see we've got our tests. And the reason why we have the different error types is because if I do something like this, we can see it's an actual improper UUID. Great. And then if I go back and just change this, I don't know, to that. So when we passed in an invalid UUID, it actually told us. Now if we pass in a syntactically valid UUID, but is not there, we're getting a not found. So again, that's why it's helpful to have these different error types as opposed to just using anyhow and smushing them down into one. if we did that, I speak from experience, you'd just get 500s for everything. But instead, by having app error, we're getting, relevant, valid, better error messages, which is really helpful. So chat show, nothing too fancy there. We're just pulling up the chat. Let's get rid of some of this. We'll come back to the component stuff in a second. So chat show, pretty standard stuff. Okay, streaming. Yeah, it's not quite as easy as it is in Python or JavaScript, I'll say that. So you'll see here, our result type is going to be server sent event for a future stream that is a result of an event or an app error. So that's our type signature. So when we post to our chat endpoint, which again would be in our API docs, actually. Now it should be API docs. We can see here, delete is going to clear it out, and then post is going to accept a payload for our chat message. In this case, it's just a string because we only it's a custom endpoint, right? We're just taking a prompt, and then we're going to return a response, an HTTP stream response. So in this case, we are taking a new message request, and you can see here the new message request is just going to be a string. So it's just a prompt, right? Prompt string, easy peasy. If it's a 200, it'll return an HTTP stream or not found or 500. So we're going to load up our chat. We're going to use that helper method on the model to create a chat message. So we'll pass in our DB connection. This is the prompt from the payload, new message request, the prompt, and then we're going to associate it with the current user's ID. And then in this case, if we double check, we can just hover. The last parameter is going to be user ID and state. So in this case, we're gonna we're not gonna pass in an explicit state. And again, state could be like pending or loaded or what have you. Now our response, because we're not hooked up to the model just yet, we're just gonna have a test response, which is placeholder. So we'll have a test response message, similar to the user message. In this case, it's just going to be this placeholder message, no user ID, no state. All right, here's where it gets a little fun. Because eventually we're going to be streaming the responses from the model, what we're gonna do is stub out our own stream. So we have a function here to create a placeholder stream. So just assume this creates a stream. And then as far as Axum is concerned, we're gonna return a new SSE server sent event stream with some keep alive. You can see here, we're passing in the event stream. Create placeholder stream, we're using that futures package. We're passing in our placeholder message, and that's gonna be streamed out. Normally there would be some helpers, so again, this is just to kind of scaffold things. So assume, given a message, a prompt, it's always gonna return placeholder. Our delete chat is a little bit different. And again, for demo purposes, we only have one chat. We're just going to truncate the messages. So normally you would actually delete it, but in this case, we're just gonna truncate. But pretty standard stuff. So find the chat and delete all the messages, which is our helper, and return an OK, or return an app error. All right, so now that that's all wired up, let's see what happens. Hi. And you can see it was a stream. It was just quite quick. So there was no chance to really see the tokens coming in. And then same deal here in our SQLite database. We've got a user message that's ready, belongs to user one. It's got the message of hi and assistant message placeholder. All right, so that's our back end logic. Let's take a look at our component code real quick. Pretty standard Svelte, non-Svelte kits setup. The things I would mention are number one, our Vite config, we are outputting it to our static directory. So this is different. And you can see copy paste. Oopsie. We're also not going to be fingerprinting. So we're not including a fingerprint in the file name so that we can always pull in the file in our Axum template. If it had the fingerprint, that would break. So for now, no fingerprints. So it's always going to spit it out as like app.js. Other things are in our package JSON. We just have a command here to build W. A little helper command to just build it and then also watch. Pretty standard stuff, I think, from last time again, Svelte 5. So if we take a look here, we are going to, using that element, we're going to parse the JSON from it, from the data adder, and then pass that in. Again, I did a deep dive in a previous video, so I'll kind of gloss over this a little bit, bootstrap it, use the data adder to read that in. We take a look here, we can see what that looks like. Yeah, so we're passing in the JSON as a data adder and then reading that in. We have our main app Svelte file. What actually is a little different from previously is we're now using, well, quite a lot different actually. We're using classes. So Svelte 5 has support for classes. And again, it just, in the last video where we left off, our chat logic was kind of getting a little smeared, a little messy. So if we just quickly go into that components from our Flask one, you can see here, it's pretty, all of our logic is happening. This is actually Svelte 4. It's all happening in our top level here. We're flashing, we've got loading, we're doing things, streaming. I thought it was starting to collapse under its own weight, so to speak. So instead, what we're doing is we're going to be relying on classes. So you can see here, chat and toast classes. And we've also got some helpers here. So there's both the chat classes and then the chat component. This is going to look pretty similar to our backend Rust stuff. So we're going to have a chunk type that'll come in later when we're doing OpenAI API compatible stuff. We've got role and state. This lines up with our Rust types. We've got our options. This is going to be, for creating a chat message. Here's the properties it expects. We've got an actual chat message class. And again, we're relying on Svelte 5. So we've got some properties here. We're doing some derives to convert a timestamp or like a date to an actual JavaScript date. Got some helpers here, again, using some derives. Got a helper here to go from the enum to the actual string. And yeah, so for a constructor, again, pretty standard stuff. We're just going to be passing in this interface, which again, this defines what properties are expected, and we're going to create it. And then we've got some helper functions to toggle the state for the chat message. Also append content. So as chunks are coming in, add it to the content. Chat options, same deal. Here's the properties a chat constructor expects. We've got our other properties. Some of them are reactive, so title, chat messages, it's going to be an array. Some helpers here for the number of messages, whether the chat's actually empty, and then our constructor. We're going to have an add message helper, another message helper to add a pending assistant message. This just kind of like cleans up some stuff and makes it nicer. And then clear message is just going to truncate it. So it may seem a little weird, but again, we're kind of like separating out some of that heavy duty logic from our Svelte code. Still using Svelte 5 runes, but again, I just found that it was really starting to kind of collapse under its own weight, just having everything directly in the Svelte component. And then Toast looks very similar to chat. Some helpers for Flash and closing. Utils, some helpers there to, again, convert between camel case, because backend's Rust, frontend's JavaScript, some HTTP stuff, throttling, debouncing, API calls as well. So this is just gonna, again, have some helpers to, make the API calls and provide us some niceties. Streaming the response, for example, parsing the SSE messages. Beyond that, the other things should pretty much be the same. So like chat message, the props have changed, right? Because now we've got actual chat message classes, but the actual logic itself is pretty standard. So I think I'll largely gloss over this. Form, same deal. So now that we understand we have our chat and Toast classes, as well as the chat and Toast components, taking a look at the top level, we'll pull in the initial chat state from our prop, which again is going to be the chat options, meaning like here's the properties, not the actual instance of the class. We're going to do an abort handler so that if we're spamming our backend, it doesn't just stack up those requests. We've got a loading flag and prompt, state, reactive state. We're going to convert from camel case because our backend versus our front end have a chat object that is based on the initial chat state after it's been converted, and then just a blank Toast. And then some helpers. When we do a refresh, we're going to scroll to the bottom, helper to reset the prompt, and then lifecycle stuff, again, Svelte 5. We're going to kill the aborter when we close out. Helper function, when we submit, we're gonna set loading, get the prompt, abort if we already have one, create a new abort, do a refresh, send the chat message using that HTTP helper, or API client, I should say. And then we're gonna get the value back. Pretty standard stuff. Clear chat. Yeah, nothing really too much there. Again, as compared to last time, the big changes are Svelte 5 overall, and then again, splitting out our logic and using classes. So if we do clear chat, it'll just clear it out. And then we can see here, right, now it's cleared out. We've got our chat scaffolded up. Let's go ahead and take a first pass at using Ollama. First pass, let's wire up our model. And to do that, we'll just take easy peasy Ollama. So let's fire up Ollama as a first pass, and then we'll go ahead and update our business logic. Let's commit our Svelte stuff. All right, so we're gonna depend on the OpenAI, this is a community one, OpenAI Rust crate, async OpenAI. Again, doing this in Python, wiring up some HTTP calls, no biggie. But given the strictness of Rust, it is a lot easier to depend on another crate. So add this as a dependency, and that's pretty much all we have to do there. Then we're also going to add in some other helpers. So we're going to add in a LLM client helper module, and as well a way to initialize it. So what this helper client is going to do is, again, just provide us some nicer interfaces, nicer functions, I should say, to work with. In this case, if we take a look at main, we are going to have some new args. So inference is going to be localhost, and model name, we're going to use 3.21 billion for demo purposes. And these are going to be additional args, command line args. We're also going to add our LLM client to our state. And when we create our router, we're going to first initialize the LLM client and then pass that in for our state so that we can then use it in our controller functions. Our LLM client, again, pretty in depth. We're going to use this async OpenAI crate. We're also going to use futures. So first things first, if we take a look, we are init LLM client, which is actually from that helper mod, which is LLM client new with defaults. So that's going to be a struct. So we have a LLM client struct, which is going to be our client, default model, token temp, some settings. So new with defaults, no problem. So we're going to have at most 512 tokens back, default system prompt, default temperature, pretty much deterministic. So this is again just a way to generate a client that we can get up and running with. We're also going to have some other helper functions to create a request because it's all typed out and it's in depth. These are just helper functions to smooth that over. So given an array of messages, it's going to create this out and call the proper APIs. And then also get the response back. So it's going to call the client with the given request. So again, all this LLM client is, it's just a helper to smooth over and provide the expected helpers that we would be using specific to our app. It's probably not something that would make sense as a crate overall in the ecosystem. This is just for our own purposes. So now that we have that though, what we can do is use it in our chat controller to actually talk with Ollama. We take a look at our chat. So this streaming in Rust is pretty involved. So really all that's changed, and there's quite a lot of changes, is around the post. So chat post stream, creating the user message, same deal. Now remember, before we were just sending a dummy stream. What we have to do now though is we're going to get the stream from our OpenAI compatible client, and then we're going to have to do some finagling to be able to wrap it and then send it back out. So this is quite a lot, but if you take a look here, we're going to get the stream from a single message, and then that's going to be our response stream. We're going to set up a channel so that as the chunks are coming in, we can then send those chunks to a task. And again, we're going to do that using a channel. So that's what this sender receiver is. Okay, we've got an abortable channel, abortable stream, so that if we close out the stream, we can kill it, and it's not just sitting in the background running. This accumulator is again just a task that we're spinning that we can just throw stuff into, and it's running off to the side. It's not going to be blocking. The reason why we need to do this is because not only do we want to send the stream responses to the user and the user interface, we also want to save them to the DB. We're going to check the response stream. If it's an error, let the user know. All right, it's still with me. So now what we're going to do is have an abortable. So we have that abort handler and the stream. We're then going to have a closure. And what we're going to do here is as the chunk results come in, if it was okay, we're going to extract the chunk. We're going to send it into our channel. What we need to notice here is that the accumulator is on the other end of that channel. So we had a content sender and then a content receiver. So the accumulator is on the other end. It's the receiver. And then the sender is what's going to send it in. And then also our accumulator. So what's happening is as the chunks are coming in, we're going to append it to our response, which is just a string. And then we're also going to create that SSE event. So create SSE event is just a helper that sends the appropriate, format for SSE. If it errors out, create an error message and let the user know. At the very end, we're going to finalize our stream, which is just going to close out our channel and send the done after it's done receiving from the channel. So right when we finalize the stream, we're going to drop it, and that's going to close the channel out. So once it's done, once the channel's done, we'll then save our chat message. And again, this is happening in a task, so it's non-blocking, which is why we can have this right here. All right, and that should pretty much cover it for our controller. So let's take a look here. We need to make sure we're running. All right, we have Ollama. Let's see, so we should be running 3.1, 3.2, 1 billion. Probably take a second to load the model.
In Ollama. And then fingers crossed, it should come through.
Okay, yeah, so we can see it came through. And if we take a look here, it also saved it to our database. Explain a CPU. And you can see the chunks are coming in bit by bit, although it went pretty quick. Okay. So first pass, we wired it up with Ollama. And this totally works, but we're in Rust land. We can do something a little different. We can write our whole stack in Rust. Let's do that. So we'll stop Ollama, and then let's use a package called Mistral.rs, or a crate, I should say. So because Mistral.rs is written in Rust, we can actually self-contain our binary. We should be able to see here, yeah, so we've added a job for bacon that is going to use the metal flag, because otherwise it would be slower. So bacon run long metal. Looks like I had my bacon file in the wrong place. That's fine. So we're going to have a new job here for metal. So we're going to add a feature flag for metal, so it uses the accelerated compute. First things first. Let's do that. So bacon, run long metal. The cargo file. So we're going to actually add Mistral, and specifically Mistral server core. So there's, in Mistral.rs, there's actually a way to import the functionality that Mistral provides out of the box into your own project. Specifically, it's the server core, so you can reuse Mistral.rs in another Axum project. No big deal. So we'll go ahead and add Mistral.rs to our project. So we're adding these dependencies. And then if we take a look here, we're cleaning up some things. Let's take a look at API client. Yeah, we're changing the shape of this a little bit because we're going to actually be getting OpenAI compatible responses back. So we need to parse it a little bit differently. We're going to drop this LLM client helper module. We don't need it anymore. In our main, we're actually going to be pulling in our Mistral server core shared types. And we are going to be dropping the parameters for Ollama. In their place, we're going to have the model we want to load. So we're going to default to 3.2 1 billion. We're going to have Mistral.rs, the engine running under the hood. And yeah, so we're also going to have a helper to bootstrap Mistral.rs. We're going to be pulling that in from from our utils. So let's take a look at that. We'll do that in a second. We also could, if we wanted to, as part of that server core package, we could load Mistral.rs in its entirety as well. So let's take a look at that. Source main. So here, if we really wanted to, we could bootstrap Mistral.rs and serve its routes. So this needs to change this Mistral server route builder. We would need to pull these from Normally you would clean this up a little bit. And now, because it's a Rust project and, because we added all of these utilities, what we can do is if we go back to our API docs, we can see we have our own endpoints, but we also have all of the Mistral.rs endpoints if we wanted to. We're not actually going to do that though, so we don't need to expose Mistral.rs. Maybe if you had your own company one, internal project, and you wanted to just expose these, you definitely could. So it's going to be rebuilding, and now we just go back to our standard chat ones. So for our main, that's pretty much it. We're bootstrapping Mistral.rs and passing it in with our shared state. So if we take a look, the logging is a little bit different. We're actually going to pull that over from Mistral.rs because it uses tracing as well, and we don't want to clobber that. The Mistral utils are going to be a little bit different too, and then our chat is going to be different too. So taking a look at our Mistral.rs utils, we're going to be pulling over quite a bit from Mistral.rs and the server core, as well as Tokyo. We're also going to have our entities that we're pulling in. So to initialize Mistral.rs, we're going to have a helper that just pulls over our model, and it's going to build it using the Mistral.rs functions and structs and stuff like that. So we're going to initialize our model. So once we do that, we're then going to pass it into our Mistral for server builder that we get from our server core utils. So this is going to take the model, it's going to turn on page detention, and it's going to create a Mistral engine that we can then call in our Rust code itself. So instead of having to do HTTP calls to interact with Mistral, we're doing it in memory directly, just in Rust. So now that we've got a Mistral instance, let's take a look at our chat. So this is going to look quite a bit different, mainly the chat post stream. Yeah, so our dependencies have changed quite a bit. So we are just going to be using the Mistral.rs utils. Again, it's got some helpers in here. You can see a lot of red. The big thing is going to be our chat post stream. From Mistral.rs, we're going to create a response channel, sender receiver. We're going to get our chat, that's the same, create a chat message, that's the same. We then have a helper though from here, from our own utils. And all this is going to do is just kind of smooth over some things. Because we're only getting a prompt from the user and not an entire OpenAI compatible request, Mistral.rs expects you to send a full OpenAI compatible payload. So because we're just getting a prompt, we're going to have our own helper that then creates a stub payload. So given a prompt, given the chat message history from the database, given Mistral.rs, let's go ahead and construct the shape that Mistral.rs expects. And this is in our utils. So you can see here, we were just looking at this. So messages is, we're going to just scroll down. So given an array of chat messages, we're going to create Mistral.rs text messages. And again, that's their specific struct. We're going to add these messages. We're going to set the system prompt if it's a system message, or rather if we include the system message. We're then going to create more Mistral messages, content role from our DB messages. So all this again is doing is just going from database messages to our type. So we're converting our database messages to the Mistral.rs format. We're also going to add in a final message from the most recent prompt from the user. So you can see here, we're adding a user message with that prompt. And then we're also going to just eventually, we're going to convert it to a vec because that's what the Mistral.rs server expects. So we've got a request here for the server engine for Mistral.rs. this is the shape it expects. And again, we're basically just passing in the defaults, which is why we've got it behind this helper. So deterministic sampling in this case, the sender is going to be from the channel. And we've got Mistral.rs, we've got our messages here. We're going to turn off thinking in this case. So again, all this helper is doing is given the messages model from the database, given the latest prompt, convert it into a format that Mistral.rs can handle. Okay, so this brings us back to our send helper. So we're going to convert it into the correct request shape. And then we're going to do send a request, which is from our server core. This is in the internals of the server core. So we're just going to have the Mistral.rs engine, have the request payload, and then if there was an error, throw one of our app errors. Go back up. We were calling this from all the way up here. So we've got our chat messages. We've got the latest prompt. We're going to send it to Mistral.rs. We are then going to create our callbacks. So Mistral.rs server supports on-chunk callback and on-complete callback. Again, not to bludgeon it, this was something that I thought was useful, so that's why I coded it out and requested it as such. So what we can do is, again, create a on-done callback here, and this is a type from the server core. So what we're going to do is just once it's done, once Mistral has done its thing, it's going to give us all of the chunks, and then we have a helper here that we can convert those to a string. So given all these chunks, convert it into a string. So we're going to get all the chunks. We're going to have our state, and then we're just going to create a chat message. And then if there was an error, we can say that there was an error creating the chat message. So this is going to be our callback that we're going to pass in. So when we create the stream response from Mistral and create streamers from Mistral, we're going to pass in that channel receiver. We're going to pass in Mistral.rs, and then we're also going to pass in an on-done callback. We don't need the on-chunk callback. That's why this is a none. If we wanted to get the chunks as they were coming, we could do some rag stuff or whatever. We've created our streamer. The user message we're also going to create because this happens ahead of time, right? So the final assistant message happens in our callback after the stream is done. And then our user message, we're going to go ahead and save it. And then we're just going to respond with a completion responder from Mistral.rs for SSE. So there is some complexity there, but we're pulling it all from Mistral.rs, and I think it is a little bit nicer because we're not doing HTTP calls to, something else. We've got a callback here that we're passing in. We did have quite a few moving pieces, but let's take a look and let's see here. So if I go ahead and cancel bacon, and if I do bacon run, you can see here run long metal. If I make this a little bit bigger, you can see here it's checking the schema. We are loading it up, the file. It's going to be bootstrapping Mistral. We can see here metal GPU. It's loading, metal prefix, dummy run, and it's ready to go. So now if we go back to our chat interface, let's go ahead and clear it out. Let's reload it, and let's say hi. And let's see here, first run. Let's see if we can get a little faster. First run's usually the slowest. Hi. Okay, so not too bad. What is a CPU? And again, the nice thing is this is happening, without a dependency on something else. And in fact, let me do cargo build -- release features metal. Yeah. So let's go ahead and build a release one because we weren't doing a release build. So while that's happening, again, we're not depending on Ollama. We don't have an external dependency there. We're not doing HTTP calls. We're just using Rust. We've got a single binary, and we're able to kind of just keep all of our logic in Rust. So I really like it, and I think it opens up a lot of possibilities. We're back, and we did a release build, metal. So it should, if all things went right, should be a little bit quicker. First run's usually the slowest. All right. Here. And high. And yeah, all right. What is a CPU? Yeah, so I think it's pretty quick. We'd have to benchmark the tokens per second. Yeah, 50 per second. We're running on metal. Yeah, so not too bad. And again, I think the benefit there is we are running it all in Rust. So I'm really excited. Having, at this point, been working with Rust for, I'd say at this point, just, geez, how long has it been? Well, at least 6 months, maybe a little more. I'm really liking it. It's not all sunshine, but I think the pain's worth it. And I'm really excited to try some new stuff. But for today, I think that's all I got for you. Thank you so much, and I'll see you on the next one.